moving from freshwater to saltwater, we have the estuaries. These are areas where we have a river flowing into the ocean, but it's got some degree of enclosure, say a bay, or maybe there's an island between the river and the rest of the ocean. And so we get in a zone of mixing of salt and fresh water. Shallow water areas at the edge of the ocean, we're going to have the tides up and down, and a lot of variation in slanting. As noted for salt marsh area, if we're at high tide, it's under ocean type water. Maybe a little less salt than normal out in the open ocean. At low tide, if it's a clear sunny day, salt water left behind in low spots is going to have evaporation. It will have extra salty water there. On the other hand, if it's a rainy day at low tide, we can have fresh water there. Or low tide, it may just be no water there. And the stuff living there has to put up with all these different changes, back and forth. A lot of change there. And of course the weather. Shallow water, storms affect these areas quite a bit because it's very shallow. And in the winter it gets cold, summer it gets warm. So, well, of course that depends partly on where in the globe you are. Temperate areas there's much more variation, tropical not so much. So living here, excuse me, you need to be able to tolerate quite a lot of variation in the environment. But if you can, that eliminates a lot of the competition. So you can do pretty well. And these areas are typically very productive. You often have a very high amount of new growth per day or year, whatever you're measuring by. So much so that a lot of the dead material then can wash into the surrounding water and be an important food source for other things. Lots of food there. Also, shallow water, we have various types of plants that can grow rooted, able to tolerate the salt water, and those provide some good places to hide. So there are a number of coastal fishes, shellfish, things like crabs, whatnot, where the larvae are often in the estuary area, and then once they get big enough to be able to a bit better manage on their own, then they move more out into their normal adult areas. So like our blue crabs here along the east coast. We have salt marshes typical of our estuaries here in the kind of mid area, much of the east coast, but when you get down to southern Florida, southernmost Texas, you start to get mangroves instead. These are trees that can grow in salt water, typical of your tropical estuary regions. Mangroves generally do not tolerate getting down to freezing, so they're only going to be in places that stay warm, but in those areas they are quite important habitats. Here's an example of a salt marsh, like what you find along much of our coast here in the Carolinas, as well as around the world, temperate coastal areas that are sheltered from the direct ocean waves. So we get these salt-tolerant grasses. Little white specks you can kind of see there are snails. Like most of the life in here, they don't directly eat the grasses, but feed on other things. In the case of the snails, actually almost farming, what they do is chew on the grass a bit, make a hole in it, and that allows fungus to grow on the grass, and then the snail can come along and eat the fungus. But a lot of it's as the grass dies, bits and pieces, dead leaves, all that, these start to decay, and now all of a sudden we've got all this yummy fungus and bacteria and whatnot growing on there, and lots of things feeding on that. Here's an example of some mangrove trees. More tropical estuarine areas. As trees, they're a bit more sturdy, so they can tolerate somewhat more ocean wave than the salt marsh grasses can. Out into the ocean, we can recognize different zones. We have the intertidal along the coast, areas that are sometimes out of the water and sometimes under as the tides come in and out. Benthic, I mentioned benthos already, on the bottom of the ocean. And pelagic is up in the water. So our plankton, our nekton, those are both in the pelagic category. Within pelagic, we can recognize neritic, close to the shore, or oceanic, way out in the middle of the ocean, far from land. So here's a diagram. Important factors, the amount of light. Up here, we have enough light for photosynthesis. So we have algae. In the very shallow water, we might get some plants as well. There are a few true plants that can tolerate the salt and grow in shallow water, but none of those float. They're all rooted to the bottom, so they can't be very deep. And of course, lots of things are eating the algae and so on up the food chain, whether it's our floating and swimming things out in the open ocean, or the many attached things to the bottom, the benthic, as well as the nekton and plankton in the shallower water here. Below our zone of photosynthesis, we have what's often referred to as the twilight zone. This is a layer where if you've got big eyes, all the bear to see with, you can see there's some light there from the sun, but not a whole lot, not enough for photosynthesis. Then, deeper still, we reach the point where there is no sunshine reaching that deep, and the only light that is present is bioluminescence, light produced by living things there. Most of the food chain down here in our twilight and dark zones is based on ultimately photosynthesis up in the shallows that has sunk down to these deeper zones. Intertidal. Again, this is where we have sometimes exposed to air at lower tides, sometimes underwater at high tides. Very shallow, so there's plenty of light. Sometimes you're in the air, or you're at the top of the ocean, so close to the air, and so there's plenty of oxygen. Typically, good amount of nutrients, but you got to be able to tolerate being underwater sometimes, being out of the water sometimes, exposed to the air. Already mentioned the challenge of sunny day, you might get extra salty as water's evaporating. Rainy day, you may get fresh water falling on you from the sky. So you have to put up with those changes. Also, waves. You have to manage, whether it's a sandy area where the sand's moving around all the time, and you have to manage to not get either sandpapered to death or washed away. Or you have more rocky areas, and they're typically hanging on is the key thing, so that you don't get washed away. But if you're hanging onto a rock, that rock is not going to move down when the tide goes down. So you have to be able to manage the changes in wet, dry, temperature, things like that. Sand, or you can just kind of dig in the sand and hide there. These are seaweeds known as sea palms, found in the rocky intertidal of the west coast of North America and some similar places. These have a somewhat sneaky approach to establishing themselves. A lot of these areas are covered in mussels, clams that are able to make threads to glue themselves onto the rock. If a sea palm spore comes along and sticks onto a mussel, the sea palm algae can grow and this sticks out into the water, and waves can catch that. Much better than onto just a mussel. And mussels with sea palms growing on them tend to eventually get washed away by the waves. Now there's a bald spot of rock, and a new sea palm spore can grow there directly on the rock, where the mussel isn't anymore. Holding onto the rock, the sea palm's got a better grip to not be washed away as well. Seagrass, moving into shallow water areas. Seagrass actually is a flowering plant. It's not the same as the grass in your lawn, but it is a monocot. They're the only true plants that grow completely under salt water. But, again, we're making some structure, not nearly as complex as a tropical rainforest or coral reef, but there's some structure there. So we have some shelter. Things can live on the seagrass or down in it. They can eat, usually it's, again, the dead pieces rather than directly munching on seagrass. The manatees actually eat seagrass. And providing important habitat. However, in pollution, too much mud washing down, these can be bad for seagrass. Also, if we do something that messes up the seagrass, it tends to be slow growing, does not recover quickly. Another type of benthic community is forests of large brown algae, kelp. These tend to be in cooler water areas, temperate, not too deep. They have to be able to get enough sunshine. These grow attached to rocks, so this is going to be a coast that's fairly rocky, not just mud or sand out there. So, of course, it's algae, they're photosynthesizing, and lots of things can grow on the kelp or hide among it if it's something that's more active like a fish. Again, not much is directly eating the kelp. So I did mention sea urchins may be a problem there, but a lot of it's the dead bits of kelp and the stuff growing on it that's what's being eaten.